Welcome to this introduction to object-oriented programming in PHP. I'm Gary Clark, I'm a software developer and a course creator, and I hope that you enjoy this 3-hour introductory course. PHP is a back-end programming language which is used by some of the biggest companies in the world and some of the best known websites and applications. It is a very popular choice for back-end web-based development and can be found in nearly 8 out of 10 public-facing websites as their server-side language. But also consider all of the non-public facing applications that it can be found in, or all of the microservices or APIs that it powers. It is a hugely popular choice and it's going to be around for a long time. It's a language which is actively supported and has a large, engaged open source community. Each year there are incremental updates which bring around excellent new features and usually an impressive performance improvement. Its object-oriented features in particular have gone from strength to strength, and it holds its own against other object-oriented languages such as Java, C++ and C#. And it is the object-oriented side of PHP which is the subject of this course. Because if you want to be a professional PHP developer these days, you're going to need to be able to write object-oriented code. It's what's used in the majority of professional applications. It's what is used in frameworks such as Symfony, Laravel and Drupal, and it's what the industry wants. There are not many modern learning resources which teach purely object-oriented PHP, and that gap is something which this course aims to address. On completing this course, you'll be able to read and write object-oriented PHP, you'll be able to recognize design patterns and write code which implements design patterns, you'll be able to test code. The code which you see in frameworks will be familiar to you and much easier for you to understand, and you'll potentially have an advantage over a lot of other developers that jump straight into using tools and frameworks without gaining a decent grounding in object-oriented programming. You can earn a decent living as a PHP developer, but in order to earn a decent living as a PHP developer, you need to become a competent object-oriented programmer, and you'll also need to have experience using frameworks like Symfony and Laravel. Consider this course a step in the right direction. This is actually the second time that I've recorded a full object-oriented PHP course, and so in this one I've made improvements on the first course which I recorded based upon feedback which I received on that course, and also based upon the fact that I've simply got 2 more years recording experience. And so here are some of the things which you can expect in this course which are an improvement on the first course which I recorded. The explanations are more in depth. The small code challenges which prove to be popular are kept throughout the whole course rather than for the first few lessons. The delivery is more engaging and at a better pace for learning, and the course is larger and covers a lot more stuff. It's very comprehensive. In this special 3-hour YouTube edit, I'm going to give you the first 3 chapters for free. That will be enough to go over the basics using some fairly realistic examples taken from the real world, such as Spotify and also e-commerce products. And we'll also touch on some of the object-oriented principles such as encapsulation and inheritance. I'll leave a link to the full course in the description so that once you complete this 3 hours, you can then have a go at the full course, and that will really take your PHP to the next level. Choose high definition for the best viewing experience, and if you'd like to join a growing group of software developers and take your skills to a new level, all you need to do is subscribe, click the little notification icon, and welcome. Before we start opening our editors and try and write code, let's have a quick discussion about what is object-oriented programming and how it can benefit us. In object-oriented programming, we combine related variables and related functions into one cohesive unit, which we call an object. I think some visuals would help us to have a good understanding of this. So I've come over to Amazon here, and we're going to have a look at some candidates for what might be objects. So I'm looking at a product here, and we could make a product into an object. As you can see, I'm signed into my account. As a user could be an object. In the top corner there you see a basket. A basket could be an object. One of the great things about object-oriented programming is that you can combine all these things and make them interact with each other. For example, as a user, which is an object, I could take a product, which is another object, and put it in a basket, which is again another object. Let's go and have a look at another example. So here I am on my Spotify account, and what we have here is a playlist. We could create a playlist object, and like I say, an object groups related variables and functions. So let's have a look at some of the variables which are related to this playlist object. As you can see, it has a name, it has a creator, which is myself, maybe another object, it has a song count, it has a length, and when we talk about variables which belong to objects, we refer to them as properties. And then we come on to functionality. So let's think about some of the functionality which we might be able to perform on this playlist, or which this playlist might be able to perform. So we can play the playlist, we can go to the next song, we can go to the previous song, we can enable repeat, we can enable shuffle. All of this functionality can be handled by methods. That is the name of functions which belong to objects. So let's have a think about some of the benefits and why object-oriented programming exists. The data and the functions that operate on that data are grouped together. We call this encapsulation, and we'll touch on it a bit more later on. We have reduced complexity. We don't have random functions scattered all over our code. Everything is grouped together with the data that operates on it, which allows for reuse. You only need to make changes in one place. So say for example, I need to make a change to a certain value or a certain variable. I know that I only need to make that change in that one place on that object, and then the changes will be reflected throughout my code without me having to go looking for random variables or random functions. Code is better organized and more coherent, and it makes it easy to visualize the design of your application. Let me round off this section by saying don't be intimidated by object-oriented programming, because OOP is your friend. It's there to help you, and it will make life much easier once you've grasped it. It's a bit of a learning curve at the beginning, but what I find is that learners that embrace object-oriented programming are the ones that progress the quickest, and they're the ones that progress the furthest. So I'd advise, have a go at all the challenges. If you do ask questions, or if you do have questions, make sure you ask them in the comments below the video. Let's get stuck in. Let's start at the very beginning, and the very beginning would be the question, where do objects come from? How do we create them? In order to create an object, you need something called a class. So what is a class? A class is like a blueprint. It's the mold. It's the thing which defines what the object will look like, what its attributes are, what its characteristics are. And so the best way to demonstrate this is to demonstrate this. So I've created a brand new project. I use a IDE called PHP Storm. If you're using something else, that's perfectly fine. You can use just a text editor if you want, or you can use Visual Studio Code. That's another very popular choice. But I've used PHP Storm for a long time, for many years, and so I've got so many keyboard shortcuts and things set up that it just makes sense for me to use this. It's not an endorsement of this editor over another, it's just what I'm used to using. So I've created a folder or a project, and I've just called it Chapter 1. So everything from Chapter 1 will be done inside of this one. And so we're just going to start off by creating a PHP file, and we'll call it Creating Classes. And so inside of this file, what we will do is we'll create a class, a very basic class. We're going to keep things nice and simple, keep the pace nice and relaxed, and then we're going to use that class in order to create an object from it. And so that class will represent a thing, and that thing in this case will be a product, like a product which you see on an e-commerce site. So how do we do this? We use a keyword called class. And so it's simply that, all lowercase, class, and then after that you follow it with the name of the class. We've said that our class is going to be called product, and this is going to be what is used in order to create products. So product, and then what you do is you use an opening and closing curly braces. And so you'll notice that I've put the curly braces like this. I've dropped down to the next line. However, This still works, you can put them after that, but the current PHP standards, the best practice, or the standards which define how you should type your code and how you should present it, the latest versions say that you should really drop it down onto the next line. And so there, believe it or not, you've actually created your first class. However, on its own, it's not actually doing much. In order to make use of this class, we're going to take it and use it to create an object. And so the way that we do this, or the way that we're going to do this in this instance, is we're going to give it a variable name. So we'll just keep life simple and we'll name the variable after the class, although we could call it anything, and I'll show you what I mean by that in a minute. So product equals, because we're making an assignment here, new, and then the name of the class, which in our case is product. So there we have created an instance of the product class. We have created an object, and we can go and inspect that object by using a var dump. So var dump product. We're just going to execute this file, so I'll say PHP and then creating classes.php, and so here it dumps out our product. So it's saying that it is an object of the product class type, and this little hashtag number 1, that is just an internal reference, because objects will all have their own individual internal references. Okay, so that's how we create a single object. We're going to use the same product class to create another product, and so we'll actually give it that name. Like I say, you can call these things, these variables, anything, as long as you stick within the rules of how you name variables. So another product equals new product, and so there we've created an entirely different object. So these two are not related. The only thing that relates them is that they've been created using the same mold, i.e. the same class. So then we can go and actually var dump both of these, and so there we have object 1, which is of type product, and then we have our object, our second object, which is another object, which again is of type product. So using a single product class, you can actually take that and use it to produce multiple product objects. Now on its own, this product class doesn't really do much, it's fairly useless. What we can do in order to make it more useful to us is we can actually give it properties. So properties are like variables which belong to a class, and you define them like this. So it's like creating a variable, except you need to precede it with a visibility keyword, and the visibility keywords in PHP are public, protected and private. We'll get more onto visibility as the course progresses. For the time being, we're going to keep life very simple, and we're just going to stick with public, because that will give us public enables you to do more than when you start restricting visibility by making things private or protected. But don't get too hung up on that stuff for the time being. All you need to know is that we're going to create a property on this class, and we'll be able to do pretty much what we want with it. And so we'll just call this name. So like I say, it's like defining a variable, and we'll give it a default value, which isn't mandatory. We don't have to give it a default value, but it's just to show you how we would do that. And so we'll just call this soap. So we have a product with a name of soap, but remember, this is still only a class at the moment. This is still a blueprint. So let's go ahead and actually create an object from it again. So this time we'll call our variable soap object equals new product, and then we can access the name property off of our soap object, and we do that using something called an object operator, which basically looks like a right arrow. Let me show you what I mean. And so what we're going to do is we're going to actually print this out. So print soap object, and then it is hyphen right angle, and then the property name, which in our case is name, but notice that we actually do not include the $sign. So when we define it, we include the $sign, but when we go to access it using the object operator, the $sign is no longer used. So let's go and print this out, and as you can see we get soap. So in order to make this a little easier to read, what we'll do is, instead of seeing that percent sign on the end there, we'll actually put a new line, and that should get rid of that for us. Okay, so we have soap, and if we want to change that name, you can do it in a similar way to which it is set. So what we'll do is we'll print it out still, and then we're going to take the soap object, and using the object operator, then name, and then we can do an assignment, and by performing an assignment it means we will actually change the name property. So instead of soap we shall have toothpaste, and then I'll take that line and do the same thing there. So we're going to access the name and print it out, then we're going to change the name, and then we're going to access it again to prove that the name has actually been changed. Okay, and so we see soap, and then we change the name, and then we see toothpaste. So now that you've seen how you can create properties, now you can access them and change them, I'll set you a little challenge. So here's what you need to do. First off, create a price property on the product class and give it a default integer value. Okay, so an integer value, not a float, so total whole numbers. Then access the price on the product object and print it, just like the way we did with the name. Then what I'd like you to do is change the price. Okay, and then do the same as what you did in step 2. Access the new price on the product object and print it. So with challenges, I'm going to keep them fairly simple and focused on the stuff that we've just learned, and I'd always encourage you to have a go at it, because that helps you just remember, or it helps solidify the knowledge which I've imparted. Okay, so give this a go. Right, so here's my solution. We need a price property, and then I'll give it a default value of 10. Okay, so that has taken care of step 1. Then we need to access the price on a product object and print it. So first off, let's create a product object. Product equals new product, and then we shall print product price. We use the object operator, and again I'm just going to add a new line here so that it just formats it nicely in the terminal. And then we need to change the price. So if you remember, it's very similar to accessing it, except you also add an assignment operator afterwards, i.e. an equal sign and then the new value. So product price equals, we'll now change it to 5, and then we do the same, we just want to print out the new product price. So let's copy that and we'll drop that down there. Okay, so let's go back to the terminal and run this. Okay, and so we see 10 because that is the default value. We created a product, we accessed the product price, which is a default value, then we changed the price to 5, and then we accessed it again, and so it printed out 5, which is the new price. So I hope you're able to have a go at that. Don't worry about having to memorize all this stuff if it's all quite new to you and you haven't touched it before, because we're going to be repeating this stuff so often and carrying it forward into the next lesson. So as the course progresses, we'll learn new stuff, but we'll always be reiterating over the stuff that we've already done, so that by the time we get to like our 10th video or something, this stuff which you've just seen here, it'll be child's play to you, second nature. In this one, we're going to have a look at methods. So far we've seen how we can create classes, how we can create objects from those classes, and how we can then give those objects data using properties. So methods, they are functions which belong to an object and allow the object to perform tasks. The way I'll start is by clearing out all of this stuff which we did at the end of the last recording, and then the price. Just going to show you something here. You don't always have to set a default value. You can actually just create your properties like this, and they'll by default have a value of null. So first things first, I might as well just demonstrate that to you. So we'll create a soap object. So soap object equals new product, and then we'll just var dump this just to demonstrate what I mean. And then to run it, I'll just make this font a little bit bigger. PHP creating classes. Okay, so not the easiest thing to read, but what we're looking for here is these bits here. So here are the properties. So we have name with it's telling us that it's a string with 4 characters and the value is soap. But for the price, we have null. So if you don't actually initialize it with defaults, then they'll default to null. Okay, so what I'm going to do on this one is show you how to create a method, and what our method is going to do is it's going to take the price. So the price will be in cents, so or the most atomic form that they can be in. So in UK it would be in pence, and then what we're going to do is we want to convert it to the currency. So if we had 100 cents, in order to convert that to the currency of euros or dollars, you'd simply divide it by 100. So this is something which you wouldn't want to be having this logic floating around in your code everywhere, because you might want to do this maybe 100 times in your web program. So this is where methods come in handy, because you can create the method. You've created it once, and then anytime you just want to see the price in currency form, then you just call that method on the object instead of having to actually write that code hundreds of times. So let me show you what I mean. We'll say soap object. We will actually set a price, and so we'll set this to 500. So in euros that will be 5 euros 500 cents. And so to create a method, we do it like this. Again, we need a visibility keyword. So I'm going to say public, and then it is the word function, and then the name that you want to give this method. I will call this price as currency, and then you have opening and closing parentheses, and then I drop onto the next line and I add opening and closing curly braces. And so this will work much the same as regular functions. If I wanted to pass some arguments into it, I could just do that here, but I'm not actually going to need them. I'm going to need to access the price, but I'll show you a special way that we do that with objects. So first off, let's create a variable. Price as currency, and then in order to access that price on an object instance, I say this, and then the object operator, and then price. And so this will refer to whichever instance you are using at the time, but I'll demonstrate that more when we actually go to call this method. So here I'm going to say this price divided by 100. So that will take our 500 here and divide it by 100 to give us 5.00. And then in order to retrieve that value, the price as currency which we've just created, I just need to return price as currency. So now let's go and try this out. So I'm going to say price as currency to store this in a variable equals, and then soap object, and then again using the object operator exactly the same way as what we did to set the price or to access the price. I can then call the price as currency method like so, and then we'll just go and dump this out. So var dump price as currency, and just to make it read a little bit better, I'm just going to put a new line on the end there. So this PHP underscore EOL, this constant here, if I actually go and look at this, as you can see, all it's doing is just adding a new line. So let's run this. PHP creating classes, and so it's telling us that it's an integer with a value of 5. Let's actually go and change the price to 550 just to demonstrate this a little bit better, and then hopefully we should see a float value. Okay, so we get a float with a value of 5.5. So 550 has been divided by 100 to give us that value. Okay, so let's have a little chat about this. So what I'll do in order to demonstrate this is I'll create a second soap object, and we'll call it soap object 2. And for this one, we're going to set the price to $6.50. I'll call this one SOAP Object 1. So now let me demonstrate how this works. When SOAP Object 1 calls the price as currency method, then this refers to SOAP Object 1 because that is the actual instance which is calling the method. So SOAP Object 1 price value is $5.50, and so that is what this will evaluate to. Whereas when SOAP Object 2 calls price as currency, then this will refer to SOAP Object 2, and the price of SOAP Object 2 is $6.50, and so in that case this price will evaluate to $6.50. So in this one we'll still see a value of 5.5. However, if I change this to SOAP Object 2, it's SOAP Object 2 which is calling price as currency, and so therefore this will refer to the object which is calling it, SOAP Object 2, and SOAP Object 2 price is $6.50. This will evaluate to $6.50, and then it gets divided by 100, of course. So let's go and have a look at this one. And so then we get a value of 6.5. So just to wrap up this introduction to methods, the usefulness of this is, like we said towards the beginning, instead of having to write this code every time we wanted to get the value as a currency, then the logic has been defined once, and all we need to do is just call that method on our objects. So this is a lot slicker than actually having to write out this all the time. And this is a fairly simplistic example. We're just dividing a price by 100, but you might have some functionality which is doing all kinds of processing and changing values on the object, in which case you could have like 10 lines, and you won't want to be repeating those 10 lines throughout your code. So if you have a method which does it for you, which can be reused on any object anywhere in your code, then it's a lot more slicker. In this one we're going to continue our work with methods, and we're going to have a look at passing arguments to methods. So I think we'll create a new file. So in the project root, which is my chapter 1 folder here, I'm going to create a new PHP file, and we shall call this class-methods. Okay, and then I'm just going to paste in some code which I've already worked out in a little practice project. This should look familiar to you. It's the product class which we created in the previous recordings, and we have our price as currency method here. So what we're going to do is actually we're going to format the currency which this is returned in, and so I can pass an argument to this method, and we will say currency, and so this will be the symbol, for example the pound symbol or a euro symbol or a dollar symbol. And then what we're going to do is we're going to actually prefix the price as currency with the currency symbol. And just thinking about that, that would be a better name, wouldn't it? So using camel case, I'm going to call this currency symbol instead. Using very descriptive names is important. It means you don't need to put as many comments in your code. It means that you can just read the code and it describes perfectly what it does, and so that's something which I'll try to maintain throughout this course. Okay, so let's create a product, and by now you'll know how to do this in your sleep. So product equals new product, and then what we'll do is we'll call the price as currency method, and we're going to print it as well, because we're going to add a string to the front of this, so our currency symbol will be in string format, and because we're concatenating something which is in string format with something which is numerical, it means that the whole lot will become a string, and so for that reason it means we can actually print it out using print. So print product, and then we'll call price as currency using the object operator. And then what we need to do is pass in a currency symbol. So I'll pass a pound symbol, and then let's go and run this. So this time it's going to be PHP class methods. Okay, and we get £1, and we get this funny little % sign after that. So what I'll do is we'll do what we did in the previous lessons, where we had this PHP end of line thing here, and it'll just by adding a new line, it means that we won't get that percentage sign, which looks a bit silly. So let's go and run this again. So as you can see, we get £1. So what do you suppose would happen if we didn't actually pass in an argument when we call this method? Let's go and run this again. And so this time we get an argument count error because we're not actually passing any arguments where the method was expecting one. And so that forces us to pass a currency symbol as an argument, but there is another way around this in which you might not need to do that, because say for example you are using most of the currencies you're going to be dealing with is a dollar symbol, and so you don't want to be doing it for every single one. If you know that 99 times out of 100 you know that the currency you're going to be using is a dollar, it can be tedious to then be calling this and passing a dollar each time. So what you can do is do what I've done here, where I've set it to a default value, so that now inside of the method currency symbol automatically defaults to a dollar. Let's go and run this. So as you can see, we now get $1, and we didn't, if you look at our method call, we didn't actually have to specify that, it just used the default. Having set that default to dollar, if I still want this to be pound, then all I do is when I call the method, I just use pound here, and that will overwrite the default. So when the method is called, whatever is passed at call time overwrites what is actually initially defined in the signature as the default. So when we actually refer to this whole thing here, public function price as currency, and that any variables and defaults, we regard this, or we call this method signature. Anyway, let's not get too sidetracked with that. Let's go and run this now, and we should see that our price as currency is now £1. Okay, £1, so our pound has overridden the dollar default. In this one we're going to have a look at multiple method arguments, and we're also going to have a look at how we can solve certain problems using something called named arguments. So what we're going to do first is we're going to add another argument to this. Now because I've specified a default value here, and because by default the arguments are read in order, if I wanted to add a second argument, so what I'm thinking of is for this here where we're using this 100, I'm going to actually pass in an argument called divisor, and we'll replace the 100 with something more dynamic with a variable, and so we can divide it by 100 or we can divide it by 1 if the currency is already in the denomination that we want it to be in. Then let's add that second argument, divisor, and here we'll say divisor. And you'll see that my editor is complaining about me, and in the bottom left hand corner it's saying optional parameter is provided before required. So this is known as an optional parameter. The reason it's optional is, like we saw, it already has a default value, so we can if we want to pass in a value and pass something which is different from the default, then we can do that. But if we want to stick with the default, then like the name says, it's optional. We don't need to actually pass a value for this. However, for this one, because this doesn't have a default value, then we need to give this a value in each instance. And so we can't do this in this order, because if we try to do this in the order that it's in, things won't work. What we'll do is we'll actually go and run this first, and so you can have a look at that error. So I'm not going to pass a currency symbol. I'm going to leave that using the default, and so now you can probably see where our problem is going to lie, because I'm going to pass in a divisor of 100, but these being positional arguments means that it thinks that the currency symbol is 100. Let's run this, and so we get an argument count error, too few arguments to function price as currency. So like I say, it thinks that the 100 is referring to the currency symbol, which means if that is referring to the currency symbol, it means that we wouldn't have passed the divisor, and the divisor doesn't have a default value. So the way we get around this current problem is we just need to switch them around. And so I'll send that to there. And so now the 100 is the divisor, and we already have a currency symbol because we've given it a default value. If we go and run this again, so now we get $1. So that's okay. What I'm going to do now is set you a little challenge, and that is for you to just practice giving something a default value and then just have a little play around with this by passing the default value and not passing it. So first things first, give divisor a default value, so that's easy to do, just give it a default value. And then, like I say, test it out by you can call this method with a default value and then call it without a default value. So pause me and give that a go. So that shouldn't pose you any problems. What I'll do is I'll set the default divisor to 1, so that means when we go to divide the price it's not going to alter it at all, so that will be quite a good default. And then you'd only actually alter the price if there was a specific need to do so. And so first off, we'll test it out by passing, so we'll pass 100, and which means we should get the same result as previous. We get $1, and then if we actually don't pass anything to our method call here, and if we go and run this again, and so this time we get $100 because we've started out with the price of 100 and we're dividing it by 1 using this default here. Let's now think about another problem. What if I just wanted to stick with this default divisor? I didn't want to change that. However, I don't want my currency to be in dollars. What would happen if I said pounds here? Let's go and run this. And so we get an error. And it's unquote type error, unsupported operand types, int divided by string. So where is that happening? And it's happening on this line here. So we have the price, which is an integer, but it's dividing it by a string because it thinks that we are passing in the pound as the divisor. So how do we get around this problem if we just want to pass a currency symbol but we're happy with the default? Because we might have 5 or 6 arguments and there might only be one that we want to change, and we might be happy with the rest of the defaults. The way we can do this is something called named arguments. What you would do here is you precede the pound symbol here with the name of the actual variable that it refers to. So in our case that is currency symbol. And so just like that, and then followed by a colon, and notice that we don't use the dollar, it's just the name of the variable followed by a colon and then followed by the value. And so by doing this it means that the divisor default will remain and all we are changing is the actual currency symbol. So nice and easy to follow really. This is quite a new edition, so you'll need to be using PHP 8 or higher. If you're not using PHP 8 or higher, this won't actually work for you. So just a little disclaimer there. Let's actually go and run this again now. And so as you can see, now we get $100. Why do we get $100? Because the price is 100. We're sticking with the default divisor of 1, so the price remains 100. However, we are overriding the default dollar symbol with a pound symbol, because when we actually call the method, we're saying we want the currency symbol to be a pound. In this one, we're going to have a look at a special kind of method called a constructor. So in PHP and also in other object-oriented programming languages, there are certain methods called magic methods. And the reason we refer to them as magic methods is that they do appear to be magic, but what actually happens is you don't call them directly, but when you take a specific action, when you perform a specific action in your code, the method actually gets called behind the scenes. So what does that mean? Let's actually go and start a new file, and a demonstration will make this nice and clear for you. So I'm going to call this new file constructors.php. Okay, and so in here I'm going to go back to that previous file, so the class methods one, and I'm just going to grab the whole of this class. So it's from where the word class starts right down to the bottom here where we have the closing curly bracket. So we'll then go back over to constructors and we'll just drop that in there. And what I'm also going to do is where we're setting default values for these at the top here, where we actually define the properties, just going to remove those default values, and then we'll go and create a constructor. You write magic methods just like any other kind of method, except a particular thing about them is that they start with double underscores. So far it's exactly the same as the method that we have there, the price as currency, and then it's underscore underscore and then the word construct. What do constructors do? Here's a definition from someone which I learned from. It says you'll use constructors to do whatever should always be done and done first when an object of this class is made. And the way I'm going to demonstrate this is to say that whenever we create an instance, an object of the product class, what we want to do is give values to the name and price properties. The way we can do that is to pass name and price variables, and then the way that we assign values to our properties is just like what we've done before, where we've used the object operator. So here what I'm going to say is this name equals name, and then I'll do the same for price. So this price equals price. And going back to what I said at the beginning, you do not call the constructor method direct. I don't call it the same way as what I did in the previous recording, where we're saying product and then calling price as currency on that. It gets called behind the scenes when you actually create a product. So let's go ahead and do that. And if you recall how we do that, it's very simple. What I'm going to do is say product equals new product, and when I hit tab in PHP Storm, you'll notice that it automatically adds these opening and closing parentheses. If I wasn't planning on passing any arguments to my constructor, I wouldn't actually need these. They're not mandatory, so I could do it like that. However, what we want to do is pass some variables to our product when we create it, and so the way we do that is like this, and that's where the parentheses come into play. And so here we're going to say name, that will be soap, and then price we'll say 100. So it's when we actually create an instance of a product like we're doing here, we pass in these variables or the values to the opening and closing parentheses, and that maps to these two arguments here in the construct method. And so now what we can do is we can go and access these methods and print them out just like we've done before. So if I say product name and then we go and run this, as you can see, we see soap. And so let's change our name to something else. Just call it tires, because I couldn't think of anything else up on the spot. If we go and print this, as you can see, we now get tires. So like I did before, I'm just going to add the new line there, and let's do the same for the price. So we shall say print product price. As you can see, we now get 100, and if I was to change this, I'll change it to 30. So what happens is that 30 is getting passed into the constructor there, the price variable, and then we're using that price variable to set the price property. So hopefully now that's becoming clear. Let's go and run this again. Okay, so now we get tires and 30. Let's now finish off this one with a small challenge. So thinking back to what we did in the previous one on method arguments, what I'd like you to do is do a similar thing here. So you can check that work if you want to, but here's the steps. Give the constructor arguments default values. So as you can see there, we've given the price as currency default values. And then if you can remember what we covered in named arguments, I want you to use named arguments to only pass a price argument. So that means that if we've given the name and the price default values, you should be able to use named arguments to only pass a price. Pause me now and have a go at that. Okay, so what I'll do is I'll go and give them both default values. So we'll go with soap, and then we'll go with price equals 100, and then use named arguments to only pass a price argument. So I'll remove both of these and I'll say price, and if you recall, we don't put the dollar in front, it's just price, then colon, and then the actual value. So the default we gave was 100 to make sure that, or to know that we are actually setting a price here. We'll give it a different value, we'll give it a value of 200. So what we should see when we print these should be soap as the default name, but we're overriding the default price with one which we are passing into the construct when we actually create the product, and that should be a value of 200. Let's go and run this, and so as you can see we get soap 200. So hope you had a go at that. If you didn't have a go with it or you weren't successful, just have a look at the previous videos if you want to, but we're going to be repeating this stuff quite a lot, so eventually after a few more videos it'll all make sense to you. Okay, so we now know how to create a constructor, how to pass in arguments, and how to use those arguments, those variables, to assign properties. You might have looked at this and thought, well, that looks like quite a lot of work there, because you've got to actually define your properties here, and then you've got to use these arguments here to then take those values and assign values to the properties. So there's really three stages, isn't there? There's defining your properties, there's passing in the arguments, and then there is the assigning the values here. From PHP 8 onwards, you can actually take care of all this stuff with a single step. And so what I'm going to do is I'm going to just remove all of this stuff actually, and we'll start from scratch. So I'll remove these, and then in the way that we did when we defined the properties, you use the visibility keywords. So I'm going to say public, and then we'll say name, and I don't have to give this a default value, but I'll do it anyway. Might as well keep it working the way that it was. So by saying public name equals soap, and then what I'll do is again using the visibility keyword public, we'll say price equals 100. So now we've actually defined the properties, we've passed in variables, and we've assigned values to those properties all in one go. The main thing which changed from a syntax perspective was that we used these visibility keywords, the public visibility keyword, before we preceded the argument, the variable name. And now we don't need to actually set the properties. This is setting and defining and passing values to the properties all in one step. Brilliant. So let's actually go and run this, and we should get the same result as before. Thinking about this backwards, then we've set the default name to soap, the default price to 100, and when we actually go and create our product, we're saying no, actually we want the price to be 200. So when we print these, we should get a product name of soap, but we should get a price of 200. Should work exactly the same way as what it did before. So let's go and run this. Okay, and so we get soap and 200. We're now going to have a look at types in PHP. The way I'm going to demonstrate this is by taking an example from Spotify. So here you can see I've got a playlist which I created, and then the playlist is made up of songs, and so we're just going to look at some of the data which is associated with this kind of thing. And so for example, if I go and look at a particular song, you'll see that it has a name, and good thing on Spotify is that it can also show you how many times the song has been played. So we'll start with some basic stuff like that, and then we can ensure that our data is of the correct type using some type hinting. So let's give this a go. In the chapter 1 folder, I'll create a class. So this, whereas previously up to now we've just been working with PHP files where we've had a class in there and then we've done some code underneath, best practice is to actually have the class and nothing but the class in the file, and then any interaction with that class will actually take part in other files in the client code. And so in PHP Storm here, I can just directly create a class. So PHP class, and we shall call this song. I'm going to start out by creating two properties. So public, and the first one will be name. I'm not going to give it a default value, and then the next one will be number of plays, so i.e. how many times has this song been played. Then I'm going to create a constructor. So there's all sorts of little shortcuts in PHP Storm. If I type underscore underscore, it'll see a load of magic methods come up here. Yeah, we've only learnt about one of those, and that is construct. So if I hit tab, then we get public function construct. So if you're using a different editor than me and you don't have that shortcut, then just copy the exact syntax as what you see here. And so as you can see here, I'm doing it the old way. I'm not using promoted properties for this one, but I can interchange the two. But we're just going to stick with doing it with the previous old school way for now. So number, name and number of plays, and then we'll assign the properties like so. So this name equals name, then this number of plays equals number of plays. And then, like I say, whereas previously we've then gone after the closing curly brace for the class and we've done our code down there, but that's not really a good practice, and you'll not see that done in professional programs. What you do is you go and create client code classes and files which will actually work with this class. So I'm going to create a file and we'll call this primitive types, because in this one we're just going to look at primitive types. At this time of recording, the primitive types in PHP are boolean, integer, float, string, object, resource, array and null. There are different kinds of types, so in addition to this you can have a class such as our song class. That can be a type. It's of type song class, and it's also a type of object. So things become a bit more interesting there, but let's stick to what we're doing here. We're just going to have a look at the primitives, and what we're going to have a look at is in our song class we are passing into the constructor a name, which you could reasonably expect that to be a string, and number of plays, which you would expect that to be an integer. But there's nothing which actually defines that as a rule, which says that this must be a string when you pass it in, and there's nothing which says that this must be an integer when you pass it in. Previously in PHP you would have had to do something like this, but this still doesn't enforce any kind of rules. It basically just some documentation where we say, okay, this is a parameter and it should be a string, and the name of that parameter is name. And then for number of plays you'd say it's going to be an integer and the variable name is number of plays. But this is all it is really. It's just documentation which is telling the developer this is the types which are expected to be passed in here, but it doesn't actually force anything. It doesn't throw any errors if you pass in a different type. So let's go ahead and try this out. Okay, so I want to have a song object, so I'm going to need to actually require the song file. So we'll say require once song.php, and then we'll say song equals new song, and then it's expecting some constructor arguments. So let's pass in the wrong types here. The name we've said should be a string, so PHP Storm can actually read that documentation and say, hey, this should be a string, but I can actually pass different values. So say for example I pass an array, and I'll just give this two different values and we'll call it a song. And then for the number of plays, let's be silly and just say number of plays as a string. PHP Storm here is complaining, saying this should have been a string, but we'll just disable the inspection just to prove that we can still pass the wrong types in here. So if I want to var dump song name, and the file that I'm executing here is php primitive types.php, as you can see we get an array. No errors have been thrown, nothing has prevented us from passing the wrong types, and I can go ahead and I can print the number of plays, so song number of plays. If I go and run this, and so we get number of plays and that silly little percentage thing. Let's go and do this again. So this time we get number of plays, but we wanted that to be an integer. So even though we've added some documentation here, the documentation doesn't enforce anything. It is what it says, it's just documentation. We can get around the issue we have by using type hints. So here, where I'd like the name to be a string, I can say string, and so that will then enforce the rule. There are some caveats which I'll speak about at the end. Number of plays, we would like that to be an integer, so we'll say int. And then if we go back to our primitive types, when I actually go to create this song object at runtime, we should now get an error because we've said that the first argument should be a string, and we're obviously passing an array, and the second argument should be an integer, and we've passed a string. So what we'll do is we will just say, and it won't actually reach this point of the program, but we'll do it anyway. We'll just say print song name. Okay, and let's go and run this again. Okay, so we get a fatal error. Let's read what it says. Unquote type error, song construct, argument number 1, name must be of type string, array given. And so that's as far as it gets. And then the error is thrown and the program stops. Let's actually change this and we'll give it a proper song name using a string. So we'll say Blackbird, and then if we go and run it again, we should now get an error because our second argument, our number of plays, is actually a string when we've type hinted that it should be an integer. So PHP primitive-types.php. Okay, fatal error, unquote type error, song construct, and this time saying argument number 2, number of plays must be of type int, string given. And so this is good. Why is it good? It's because it makes your program more predictable. You know that you're not going to get the wrong types passed in there, and so that your program's not going to behave in strange, unexpected ways. By type hinting these, by adding that strictness, it means that you will always get the type that you are looking for and the type that your program is expecting to work with. And if not, an error will be thrown, and errors can be handled in all kinds of ways, but we'll look at that when we get later in the course to error handling. Let's change this to an integer, so we'll say 1, 2, 3. And then if we go and run this now, this should work. So we get Blackbird. And then let me show you what I was talking about when I mentioned caveats. What if I wanted to pass an integer as the name, or accidentally an integer got passed as the name? If we go and print this out, as you can see, it's actually printing 1, 2, 3, 4. Even though this is an integer and we are expecting a string, we don't have an error. So let's go and actually inspect that variable. So the way to inspect variables is to use a var dump. So I shall place that in here. Song name. And so it's saying that it is a string. So even though we've passed an integer, it actually, in some instances, PHP will try and figure out what you're trying to do, and it will cast things like integers to strings if a string is what you have type hinted. If you don't want that behavior, if you don't want that default behavior, what you need to do in the file which is actually calling the methods, or the file where the object is being created, you need to do this. Declare strict types equals 1. And as you can see, as soon as I put that in there, we get a squiggly line underneath this 1, 2, 3, 4, and then in the bottom corner there it's saying expected parameter of type string int provided. And if we go and run this now, so we now get an uncaught type error. And so back to the error that we had, argument number 1 must be of type string int given. So I'll change this back to the way it was, and just to reiterate, this line here, it needs to go in the file where the code is being called, not where it was implemented. So not in the song class itself, but in the primitive types file where we're actually newing up that song object. If we go back to our song now and look at the documentation we added for our construct method, it now becomes redundant because our type hints are saying what type of variable this should be, what kind of data it should hold. It should be a string, and same for this one, this should be an integer. So do we really need this noise here? It's best to actually leave stuff like that out, and we sort of have self-documenting code now, don't we? So we don't need to add unnecessary comments. In that last one we had a look at type declarations using primitive types, so things like booleans, integers, strings, floats. In this one we'll have a look at class type declarations, and we'll stick with the similar theme. So in the last one we looked at a playlist and then we created a song class. In this one we'll create a playlist class and we'll look at ways in which we can add songs to the playlist. So it should be fairly interesting. Over in the code, in the chapter 1 folder, we'll create a new class and we'll call this playlist. Okay, and so this playlist can hold more than one song, so I'm thinking straight away we'll have a songs array and we'll default it to an empty array. And then we want to be able to add songs to that songs array, and so we'll create a method and we'll just call it add song, and then that will take a single parameter which will be a song. And so you'll hear me use the terms parameter and argument interchangeably. So the official way that it works is like this: when you declare the method, it is referred to as a parameter. It's a method parameter. But when you're actually calling the method, so if I had some code down here and I was calling the add song, then the values which I passed into that, you would refer to them as arguments. But a lot of the time people don't make the distinction between the two. You'll hear people refer to them more often than not simply as arguments. But like I say, when we're referring to it in the actual declaration of the signature, when we're actually creating the method in the first place, then technically this is a parameter. Okay, so let's go and add a song to that songs array. So we can do that by saying this songs and then opening and closing square brackets equals song. And by doing that, what it does, it adds this song, which is this song, to the songs array. Let's go and create a file where we can try this stuff out. So this will just be a simple PHP file and we'll call it class type declarations. Okay, what we're going to need here, we're going to need our playlist, and if we want to add songs to the playlist, we'll also need to require once our song.php file. Okay, so let's create a new playlist. And then we'll create a couple of songs. So what I'm going to do here is just demonstrate the reasons why we should use class type declarations in the first place by doing something which would be wrong. So song1 equals, so we'll actually create a song first off. We need to give it a name, and then we'll give it number of plays, which is 100, and then we'll create one called song2, but this time, even though it should be a song, I'm actually going to break that rule and just add a song title. So this is a string, but this is a song object. Then what we'll do, we'll add both of those to the playlist. So playlist, add song, we'll add song1, then playlist, add song, and we'll add song2. And so just to prove that those have both been added, we shall print the count of playlist songs. Okay, so the count function simply counts the number of elements in an array, and we said that our playlist songs property was an array. So let's go and print this out now. PHP class type declarations, and so as you can see, our answer is 2. So if our songs array contained only songs, then we should reasonably be able to loop over the songs array and print the name of each song. So let's go and do that and let's see what happens. For each playlist songs as song, and then we're just going to print song name. We'll put the new line on the end there. So let's go and print this out, or let's go and run this and see what actually happens. Okay, so two things happen really. First off, because the first song did have a name, it was our song object, it's actually gone and printed that on the first pass, and so that's why we see Blackbird. However, when it gets onto the second iteration of the loop, it says PHP warning, you are attempting to read the property name on a string. And it actually gives you the line. So it says class type declarations on line 16. So it's actually got as far as here. But that's not great. It would have been better if we could have had some protection so that we didn't get so far into the program, which would have created an error when we tried to add a song, but what we did is we actually added a string. We don't want to allow this. So how can we protect ourselves from this? And the answer is to use class type declarations. So let's go back to our playlist. And here where we're saying add song, what we want to do is actually add the type declaration there, song. And so that means that if we try and pass anything other than a song in here, then we'll get the error nice and early. Our program will stay predictable because it won't get any further. We'll know straight away what the problem is. And so let's go back to our class type declarations and we'll just run this again. Okay, and so this time we get a PHP fatal error, uncaught type error, playlist add song, argument number 1 song must be of type song, string given. And again it says called in class type declarations on line 12. So this time it's been called earlier. We haven't even got as far as our loop, which is good news. It's actually created the error here where we've actually tried to add a song, but it wasn't a song, it was actually a string. So let's actually go and change this. We'll comment out that one and we'll make it so that it works. So song2 equals new song, the title will be yesterday, and then the number of plays, we can just make something up, number 400. So we then go and add song 1, we add song 2. This time it should work because it is an instance of the song class, and we should be able to loop through those then, because we know each song will have a name, so we should be able to loop through and print out the name of each song. Let's go and run this. Okay, so that's what it does. It goes through, prints out the name. So hopefully you've seen the value in that, seen the reason why we do it, and as you can see, it gives us that layer of security. We know we're not trying to pass things into our songs array, which shouldn't actually be in there. Nice protection. In this one we'll have a look at return type declarations. So we use these to enforce a particular type which you want to be returned from a method, to make sure that the code which calls those methods isn't getting expected values back, it's getting the type that it wants. So what we can do here is we'll actually go and make sure that when we ask for the length of this playlist we get an integer back. So public function, we'll say get length. And so the way that you declare a return type is after the closing parentheses of the method name we add a colon and then the type, and so for this one it will be an integer, and then we drop onto the next line and we add our opening and closing curly brackets. And so I'm just going to say return count this songs. Okay, and then I'll create a new file which we'll use to play around with this, and we'll call it return type declarations. Okay, and so what I'm going to do is actually borrow some of the code from the class type declarations, and we'll just require once the playlist, we'll get the song, and then we'll get from down to here. That should be pretty good. We'll copy that over, drop that in there. I'm just going to remove that, and so it adds 2 songs, and then what we'll do is we'll check the playlist, and if it's shorter than 10 songs we'll print out a message. So if playlist get length is less than 10, print short playlist. Okay, so we only added 2 songs, so we should see that message here. So PHP return type declarations short playlist. However, if we went back to our playlist and for whatever reason this method was returning a string instead of an integer, so we'll just hard code something in there. I'll call it 4 songs, and then if we go on and run this, so now we get a PHP fatal error, and look what it says: unquote, type error, playlist get length, return value must be of type int, string returned, because we returned a string from the method when it's actually meant to return an integer. And by forcing or by declaring that an integer should be returned, it means again that the code which uses it knows it's predictable, it should always reliably receive an integer. This was a bit of a silly example because we just hard coded in 4 songs there, but you can imagine that this method might be doing lots of other things, and so it could get caught up in situations where it is possible for it to return the wrong value, especially if it had received the wrong type of values as an argument. But again, like I say, it's just an example to show you how type returns actually work. So we'll finish off by changing this back to the way it was. Count this songs, and then we'll run it again. Okay, great. If you have methods which don't actually return anything, you can use a special pseudo type, and that is void. And so when I'm adding the song here, it's not returning anything, it's just adding a song to the songs array. So here, because I want to say that I'm not returning anything, then I can just say void, and then my code will know what to expect there. In object-oriented programming, there are 4 principles, which are encapsulation, abstraction, inheritance, and polymorphism. So all quite long words, but don't be put off by the names. We're going to start off and concentrate first on inheritance, because it's possibly the easiest one to understand, and it's certainly the easiest one to demonstrate at the level that we've got to so far. And so, in a nutshell, inheritance means you can have a class which inherits from a parent, and so it will inherit its properties and its methods, but it will also be able to declare its own properties and methods which are different or in addition to the ones that it inherited from the parent. And so for this reason we say that the child class is extending the parent class. The way I'll demonstrate inheritance is by showing you some of the problems which it can solve. And so we're at the start of a brand new chapter, chapter 2, and in here I'm going to create a new class, PHP class, and we'll call it book. And so we'll start off just by giving this book some simple properties. So a book will have a title, it will have an author, and we'll also go with price. And then I'll create a constructor, and so here we'll say string title string, and so for price I'll go with an integer, which might surprise you, but it's what I do most of the time, and also in a lot of professional applications they go with the most atomic unit of currency. So for example, if we were working in euros or dollars, then our price would be in cents, and then if you actually wanted to make that into dollars or euros, then all you would do is just divide it by 100. Okay, but let's not get drawn into that. Let's initialize our properties, and so this title equals title, this author equals author, and this price equals price. I'm going to add 3 certain kinds of methods called getters, and basically what they do is just they're methods which give you access to those properties. But when we get onto visibility, and these will make more sense then when we're dealing with protected and private properties, but for now just go along with it. And so the way that we'll create them, they're just getters are simply methods. So public function, and so we'll say get title, and so this will return a string, which will be the title. Okay, and so I'll let you have a go at doing the others. So all you need to do is do the same as what I've done there, except we need getters for author and price. So pause me and have a go. This is what you needed to come up with. So I added the get title one, then the same again, follow the same format. Get author, notice we're using camel case, and that is returning a string, and for the price I've actually put string, but it should be integer. So again, for price, get price, returning an integer, and that returns this price. Okay, so let's go and create a file where we can go and actually create some books or create instances of books. So in the chapter 2 folder, I'm creating a PHP file, and this will be called inheritance.php. And so let's think about different types of books. So the different types of books we're going to deal with in this instance is we can have physical books, i.e. books which are made of paper, and then of course there are digital books, which are books which you can download. So two very different types of books there, and I think this example will be good for demonstrating the difference and for demonstrating why inheritance is useful. So the first one we shall call physical book equals new book. So we need a title, so we'll just call it a random book. The author, we'll say Jane Doe, and the price 2,000, so that would be like €20, $20 or whatever, and then we'll copy that, and then we'll call this one digital book. And so this can be the very same book except in digital format, and so you'll notice that all the properties and everything, we can use exactly the same ones. And then if we wanted to, for example, print the author, it would be the exact same thing for both the physical book and the digital book. So say physical book, get author, and then we'll put a new line on the end of there. And we'll do the same for digital book. And so let's go and run this. So we're in chapter 2, PHP, inheritance, and it's saying book not found. So we forgot one step, and that is to require once book. Okay, apologies for that. Let's go and run this again. Okay, so exactly the same, our two books, even though we've said that one is a physical book and one is a digital book, there are no characteristics which distinguish them, which make one obviously a physical book and one obviously a digital book at this stage. But if we did want to have the characteristics of physical books and digital books, how would we go about this? So one way would be to just go back to our book class and start adding properties which refer to each of those kind of books. So let's take that approach first. If you think of a book in terms of a product or something which needs to be shipped, then a physical book would have a weight, whereas a digital book is more likely to have a file size. And so one thing you'll notice about those is that a digital book wouldn't have a weight and a physical book would not have a file size. Let's go and add these to the constructor. So I'm just adding them both as integers. And so again, the way we'd think about that is weight would be in grams and file size would be in kilobytes. And then down at the bottom, I'll go and add getters. Using PHP Storm, by the way, if you're using the same as me, apologies if you're not. On a Mac, I can hit Control and Enter. And then this little generate menu pops up. If I go to getters, I hit that, and it will say choose the properties. So I'll choose both, I'll hold shift and press down to choose both weight and file size, and then hit enter again. And so as you can see, it's added those getters. You'll also notice that in my case it's added these doc blocks here, which are little comments which tell you something about or give you some metadata regarding the methods. I don't actually need this one here. All it's saying is that it should return an integer. However, I've used a return type declaration as integer, so let's remove some of the noise, which is a good practice. We call this self-documenting code, when instead of having comments and doc blocks, if you're using nice descriptive names and you're using return type declarations, then you don't actually need comments to say what it does or what the variables are, etc. It's already done for you. So let's go and move it from here. Also, one thing I will do for weight and file size is actually set up some default values. So int weight equals 0 and int file size equals 0. And we'll also drop these on to their own lines just to make it a little bit tidier. And so one thing you will have noticed now is that regardless of the fact that this is a physical book, it actually has a file size. So if we say get file size, and our digital book has a weight, so we can say get weight, and we'll go and print these out. And so as you can see, they have values, but a physical book would not in real life have a file size, and a digital book would not have a weight. So we're starting to introduce redundancy into our book class. And if you can think of all the differences between a physical book and a digital book, if we decided we want to add more properties and more characteristics which refer only to physical books or only digital books, then the class is going to start to get quite unwieldy, and there's going to be a lot of redundancy in there. So that is what you would call a code smell, and probably an indicator that you should think of a different way of going about creating your book. Now let's look at another problem, or another example of a problem which inheritance solves. Say for example we wanted to do something like this. We wanted to be able to print the title and the author, and then in the case of a physical book we wanted to print the weight, and in the case of a digital book we wanted to print the file size. Then we would have to be doing something like this. We would need to look and check for a distinction between the two and say, is this a physical book? Is this a digital book? And in which case we'll print the file size, but if not, if it's a physical book, we'll print the weight. And so that means we'd have to introduce another property, or a way to distinguish between the two, by adding a type property. So let's go and add that type property now. So now we've added an extra property which is type. We've added it to the constructor and we've set it like so. And so that really is just one example of how you can start ending up writing a lot more code to make that distinction between the two, and checking if this type of book do this, if this type of book do that. But there could be multiple other examples. If you think about the differences between a physical book and a digital book, one of the main ones would be one of them you simply download, the other one needs to be dispatched or posted to a physical address. And so again, do you want to be doing these kind of checks? If physical, then do this and send to the address, and it's going to get really messy. And so there must be a solution, a better way of dealing with different types of books than having to add all these multiple conditions and all this extra code like so. Because ultimately, if we carried on down this path, our code would become harder and harder to manage. We'll go over to our inheritance file and we'll actually implement that anyway, but if you notice this, we have to pass in the strings physical and also the strings digital, so there is the potential for typos and things like that which could bring in bugs. This is basically just not a great solution, but we're going to do it anyway just to demonstrate it. And so here we will print the physical book, and then again we shall print the digital book. We'll go and run the file. Okay, so we get a random book Jane Doe with a weight of 0, and then a random book Jane Doe with a file size of 0. So let's consider alternatives. One alternative would be to have two different types of books. That seems logical to me. So we'll have a physical book and we'll have a digital book. So let's go and create those now. I'll start off by creating a physical book, and then I'll add only the properties which a physical book should have. So I'll go over to my book I'm just going to steal some of the code from the top here and then remove the stuff which is relevant only to digital books. Okay, so we'll drop that in there. So what we need to get rid of is type, because we don't need that anymore, because we know that this is a physical book, and we don't need file size. So again, I'll remove that from the constructor there, and then we'll remove it from here. So far so good. And what I'll do is I'll quickly drop my getters in there also. Here are my getters and setters, and then I'll also add a print method. But the difference is that this print will be only relevant to a physical book. Like so, it will print a title, author, and the weight, and notice that I no longer have to do those checks to see what kind of book it is, because this is relevant to only a physical book. Let's do exactly the same thing for a digital book. In fact, what I'll do is I'll let you have a go at this. So you've seen what I've done there. I've taken the parts from the book class which are only relevant to a physical book, and so what I'd like you to do is in the chapter 2 folder create a class called digital book, and then take only the parts from the book class which are relevant to a digital book. And also I'd like you to do what I did with the print method for a physical book. Do the same, but make it relevant only to a digital book. So pause me and I'll do the same behind the scenes. Here is my digital book. As you can see, the main difference, the one distinguishing difference between the two is that this one has a file size instead of a weight. And so we've also added the getters, which is all fairly standard, and then you'll notice the difference in the print method. This shows a file size instead of a weight. So let's go over to our inheritance file and actually try out some of those differences. So I'll start off just by editing the ones that we already have in place. So this one will say a physical book. We don't need a type anymore, but we do need a weight. So what we'll say 300 grams, and then for the next one, this will be our digital book. So digital book, and then as the fourth argument, what we need is the file size. So we'll say 1048 kilobytes. And so we'll leave it the way it is. As you can see, it's already calling the print methods. So let's go and run this. And I've made the same mistake as what I made before, so we need to actually require physical book, and we need to require digital book. Let's run this. Okay, so we can see our two differences there. A random book, Jane Doe, weight 300 for the physical book. A random book, Jane Doe, file size 1048 for the digital book. One thing which will no doubt have occurred to you is that we still have some duplication here, don't we? So every time I create a physical book or a digital book, I still need to create it with the same three arguments each for both of these, which should indicate to you that this can still be improved further. But let me show you a way in which this duplication can be a real problem. Say for example we want to show the price as the currency. So at the moment we're getting the price, but if this is in dollars, this is coming back as cents. What if we wanted it to come back as dollars? So we'll add a method to our physical book, and we'll call this price as, or get price as currency. And so this time this is going to be returning a float. So return this price divided by 100. So that might be a business requirement that someone in the business has said, okay, we want to be able to display this or show this as dollars, and in that case a nice way to handle that is to add a method like this. But if we're going to need that for a physical book, then we're going to need that for a digital book. So let's go over to our digital book and we'll drop the same method in there. Okay, so far so good. Let's go and actually try this. Get price as currency, and again for the digital book get price as currency. So we're not seeing anything particularly extraordinary here. So as you can see, we're printing that out as $20 now. But then you might get something like requirements which come from the business and say, no, that's not quite what we wanted. What we wanted to do is we wanted to see that as with a $sign in front of it. So then we need to go back into our physical book, put the $sign in front of there, and then of course you're going to need to go and do the same for your digital book. So any change that you make in one, because you have that duplication, because you're using the exact same properties in both and the same methods in both, it means changes to one involve a change to the other. We'd even end up having to change the return types here, because this would also need to be a string. So even though our design feels like it's improved somewhat, and this is more, our properties are more relevant to a digital book, our properties are more relevant to a physical book, and some of our methods have improved, they are more relevant to the actual class that you're dealing with, redundancy remains a problem, and it's one we need to fix, and we're going to fix that with inheritance. We need to solve this problem that we have with redundancy and duplication. The answer is inheritance, and so what we're going to do here is we're going to inherit from a parent book class using our physical book and our digital book. The way to go about this is to look at our physical book and our digital book and see what are the commonalities there, what could be extracted into a parent class, and then take it from there. And so if we look at our physical book here, we have properties title, author, price and weight. Let's go and look at our digital book, title, author, price and file size. So you'll have noticed there that title, author and price are common to both of these physical book and the digital book. And so let's go to our book class, because we're going to use this as the parent class. And so we have title, author and price, and everything else is going to be specific to the child classes, and so we can remove those from the book class, the parent book class. And so I'm going to remove the setting of those properties, and I'm going to remove all reference to those things. And so here where we are printing, this old print method, file size, weight, all of that will go. And so now, as you can see, we have a much more streamlined book class. Let's just go back to the physical book, and there's one other method, get price as currency. So we'll actually cut that from the physical book and we'll just drop that in here, and while we're there we'll go and cut that from the digital book as well. And so let's go back to our parent book class and see what we have. We now have three properties, title, author and price, and then three getter methods for those, and then we have this one which we created for get price as currency. And now we want to make our digital book and our physical book children of this book class. How do we do that? Let's go over to our physical book first. The way we do it is we simply say extends. So after the name of the class, physical book extends book. And then what we need to do is we need to require once, and so we're going to require that so we have access to that parent book class in this file. Later on in the course I'm going to show you how we can do something called auto loading, which means you won't have to require files in other files, and it'll be a lot nicer system, but we'll take things one step at a time. And so our physical book now, because we've said that the title, author and price are going to belong in the parent, the physical book will actually inherit those properties, so it means that we don't have to declare them here. Let's go and remove those, and so the only property we're declaring in our physical book now is the weight. The constructor, I'm going to delete it initially. We are going to write a constructor shortly, but for the time being we're just going to delete that. And so again, like I say, because the title, author and price are being inherited, and because the book class which we are inheriting from already has public get title, get author and get price methods, it means that we don't need to duplicate them, we don't need to redefine those methods here, so all of those can go. And as you can see, this is becoming a lot smaller now. Let's go over to our inheritance.php file and have a play around with this. And so I'm just going to delete the reference to the digital book for the time being, and I'll also delete these lines here. So physical book equals new physical book, and then we're setting these first three properties, so the title, the author, and also the price. So what happens if I now decide to say that I want to print out the author? Print physical book get author, and we'll put our new line on the end of there. And so a couple of things here you've probably noticed. We didn't actually have a get author method on the physical book. We don't have one there. The get author method is on the book class, but we can actually call it on a child class, and it will call the parent's get author method. So it's inheriting the methods as well as the properties. So hopefully we're clear on that. Another thing you'll notice is that we're passing these arguments in here, and so how will these get set? Because our physical book also does not have a constructor, and so in just the same way as it's actually the get author method on the parent book class which gets called, well, when we actually pass these arguments in here, it is the parent's constructor which gets called behind the scenes. And so the title, the author, and the price will all get set using the parent book's constructor. So this code here will be executed. Let's go and actually run this, and then we can see it in action. And so as you can see, we get the author's name, Jane Doe. What about if I want to call this print method on the physical book? Let's actually go and give that a go. Okay, and so we see a random book, Jane Doe, and then weight, but there's no actual value for weight. At the moment, if we want to set the weight, we need to sort of do it manually like this. Physical book weight, and we'll just set it to 300, and then we'll go and run this again. Okay, good. So we have a title, we have an author, and now we have a weight. But you're probably thinking, well, that's not what we want to do. We want to be able to set the weight through the constructor, just like we did when we did these properties here, the title, the author, and the price. In order to be able to do that, we're going to need to create a constructor in the physical book, but if we do that, then how will these properties get set on the parent? We'll tackle that in the next one. Okay, so over in my physical book, I'm going to create a constructor. So public function underscore underscore construct. And so my one and only property for the physical book is the weight. So we're going to start off by just setting that for now, but you might be thinking, or you may not be thinking, that there could be a problem with this. So this weight equals weight, and so you'll see the squiggly line under construct, which is probably giving you a hint that there's a problem with this. But anyway, let's go back to inheritance, and I've set the weight there, and so you might be thinking, okay, so we'll just add it on to these other arguments that we're passing in, so say 300, and then we don't need to add the physical weight. And so let's go and run this. Big explosion. And so it's saying uncaught type error, physical book, argument number 1, weight must be of type int, string given. Okay, and so what it thinks is that this string here, random book, it thinks I'm actually trying to set the weight. And the problem is that when we create a constructor in a child class, we still need to have a way of adding these arguments or these properties to the parent. It won't automatically do this because once I've created this constructor in the child, in the physical book, it now overwrites the constructor in the book class. So the constructor in the book class is now completely ignored, and it's this construct method which gets called. The child takes precedence, and so we need to find a solution, and the way to do that is to actually pass all the arguments that the parent expects, and then inside the construct method in the physical book, actually call the parent construct method. So you might be thinking this is becoming complex, but let me show you what I mean by that. So the first argument was the title, and then the second argument was the author. The third argument was an integer, and that was price. And so that's the three arguments that the parent requires, and then we'll add another one for the weight. And then what we do is we call the parent constructor inside of this constructor, and the way that we do that is we use a special keyword called parent. So what this will do, it will then reference the parent class, which in our case is the book. And so you don't call parent methods inside a class like this. That is only when you're using objects. So when you have a physical object, when you've created an object using the new keyword, the way that you call parent methods is you use something called a scope resolution operator. And so that is simply 2 colons, and then we say construct. And then what we do is we just pass those first 3 arguments. So these values will now get transferred into here. So title, author, and price. So now we've taken those values or those arguments into the physical book constructor, and we're then passing them into the constructor on the parent method, which means that that will get called. So if you have a look at a book, that will get called, and then title, author, and price will get set. But how do we set the weight property on our physical book? The way that we do that is you can do this before or after the parent construct method, but it's more typical to do it afterwards. Is we just exactly the same as what we did in the book class. We say this weight equals weight, and then what will happen is all 3 of those properties will get set on the parent, and then this weight property will get set on the physical book. So now we just need to go back to our inheritance.php and make sure we have 4 arguments. So we have the title, we have the author, we have the price, and now we have the weight. And so if we go and run this, and it's going to call the print method on the physical book. Great, so we get the title, we get the author, we get the weight, and we can again do all the other stuff. So I could print physical book, get title, and again it's going to be the get title method on the parent which gets called. Let's go and have a recap on what we've just done there. So over in our physical book, we've created a constructor. We're passing into the constructor all the requirements of the parent, i.e. the book class, and then the one single property which is specific just to the physical book. We took the ones which are specific to the parent, and we've set those using the parent keyword to call the parent, and then the scope resolution operator, which is these 2 dots, and then the construct method means that we can actually call the parent. We've set those properties that way, and then we've set this weight property on the physical book. I'm now going to set you a small challenge. So you've seen there what we've done with the physical book and how we've inherited from the parent book class. What I'd like you to do is do the exact same thing using the digital book. And so think about the constructor, think about what we did with the properties, how we removed them, think about how we extended the parent book class, and how we actually built up the constructor. I'll not give too much away because you can just have a look at the physical book and see the changes that we've made there, and also think about some of these getter methods which are no longer required in the digital book because they're being inherited from the parent. So have a go at that, and then what I want you to do is just do the same as what we've done in the inheritance.php file. Create a digital book or new up a digital book, and then just print out some parts or reference some parts. For example, you could print out the file size because that's specific to a digital book. You could also call the print method because that has parts which are also specific to the digital book. So have a go at that and then come back and see how I did it. Okay, so I'm going to go over to the digital book, and the first thing I'm going to do is I'm going to extend book, and also remember that at the moment we need to require once the book.php file, and then title, author and price. Those are all properties which we left on the parent class, the construct method. So what we're going to do here is we're going to leave these title, author, price and file size, and then what we will do is we will call the parent. So parent colon construct, and then it is title, author, price, and then we can remove these here because we don't need to set them in the digital book. They're now going to be set in the parent, and the only one which is being set in the digital book is the file size. Then get author we don't need, get title we don't need, get price we don't need because they are all in the parent book class. Get file size we shall keep because that is specific to the digital book, and the print method has also been written specific to the digital book because it accesses the file size property. And so let's actually go over to the inheritance.php file, and we'll new up a digital book. So digital book equals new digital book. I'm just going to copy some of these properties here. So the price, title, author and price, and then for file size we'll just say 1048 kilobytes. Okay, and so I'll get rid of these bits here. We'll print out some stuff which is specific to the digital book, and so digital book get file size, end of line, and also we'll do digital book print. Okay, so let's go and run this, and as you can see it prints out the file size, and then it prints out information regarding the digital book, title, author and file size. So how did you get on with that? Hopefully you gave it a go. Really quite simple now. The main things you need to remember is you're extending the book class, and then any properties which you want to set on the parent, you do that by calling the parent constructor within the body, i.e. within the curly braces of the digital book constructor, and then any properties which are specific just to the digital book, you can set them on their own. And then we removed all the redundant methods which came from the parent book class because they can be inherited. We can still call those using our digital book, and we just kept the methods which are specific to our digital book. Let's have a look at how methods in subclasses overwrite the methods in parent classes. And so let's go over to our physical book, and here we have a print method. So what I'm going to do is I'm just going to copy that, and we'll go over to our book, and I shall drop it in here, and then I'm just going to remove this part after the comma to the end, because obviously the book we're not going to include weight. That's just going to be something which is specific to physical book. And so title and author, these are properties which are created in the book class, so all is good here. And what I'm going to do is, first off, we're just going to create a book object, so not a physical book, an actual book object. So we'll go over to inheritance, and we'll clean out some of this stuff. In fact, what I'll do for now is I'll just comment out this stuff because I might need it in a minute. So we'll say book equals new book, and then I need to give it a title. And so now I should be able to print the book. So book print, and then put on the new line as well. Okay, so if I go and run this, PHP inheritance.php, so as you can see it now prints random book and Jane Doe. If I went to my physical book and I commented out the print method, then what would happen is the print method in the parent would get called. So let's go and actually create a physical book, and then we'll say physical book print. I'll delete this part here. Okay, and we'll just comment out the book also. So now I've created a new physical book and we're calling the print method, but we've actually commented out that method, which means that it will then defer up to the parent. So as you can see now it's calling the parent method, so we only get to see the title and the author. So just a reminder there, if we look at the print method on the book class, which is the parent, we see just the title and the author. However, if I go back to physical book and I uncomment this, then now this print method, if I call this on the physical book, will override that of the parent, and it's this one which will actually be called instead. So let's go and run this once more, and so this time you should also see the weight. Okay, so hopefully that's clear. Basically, any methods with the same name on a child class will overwrite methods of the same name or override methods of the same name on the parent class. The child class takes precedence. One very important thing to know is that whilst a child can access the methods on a parent cannot access methods on a child. A parent should know nothing about a child. So if you try to put stuff in a parent class which presumes some kind of knowledge of the child class, then that's bad code and it's something which you shouldn't do. So let's have a look at an example of what I'm talking about here. I'll uncomment this, and then in the book class what I will do is I'll try and access a method off of the physical book. So the get weight method is a good one because that exists in the physical book but not in the book. So if I go and paste that in there, and we shall comment this stuff here, and so we get an error, and the error says uncaught error, or PHP fatal error, uncaught error called to undefined method book get weight, and it gives you the name of the file, inheritance line 7. So basically it's saying it's trying to call a method which is undefined on book. So it works one way down. Child classes can access methods which are on parent classes, but parent classes cannot access properties or methods which are on child classes. They should have no knowledge of child classes. In this one I'm going to introduce visibility. So up to now, when we've created our properties, we've declared them all as public, but you've actually got a choice of 3 different visibilities, and those are public, protected and private. In order, this is what they do. Public properties and methods can be accessed anywhere in your code. Protected properties and methods can only be accessed within the declaring class or a subclass of the declaring class, and private properties and methods can only be accessed within the declaring class, and they are not visible anywhere else. So that's the rules, but what does that actually mean in real life? Let's go and demonstrate this, and I'm going to be really explicit and use really explicit names. So we'll call this class base class, and then we'll create a subclass of that, which we shall call subclass. Okay, and so in the base class I'm going to create a public property. So nothing new here, this is what we've been using up until this point, and we'll actually call it public property as well. Obviously we could call it whatever we want, and then for the default value I'm just going to actually paste in the rule, which is this: public properties and methods can be accessed anywhere in your code. And so just to demonstrate that once more, let's actually create a file called visibility, and then here we shall require our 2 classes that we've just created. So we're requiring baseclass.php I'll do the very same thing for subclass. Okay, and so what I'm going to do is create a base object from the base class. So base object equals new base class, and then we shall print our base object public property. So print base object public property, and then we'll add our new line there just so it looks okay in the terminal. And then let's actually go and run this. So PHP visibility.php. Okay, no problems there. Public properties and methods can be accessed anywhere in your code. So a public property can be accessed in the class itself, so it could be accessed in the base class. It could also be accessed in the subclass, so it can also be accessed off the subclass. And what we need to do is actually make sure that our subclass is extending base class. And so now that we've done that, now that subclass is a child of base class, we can go over to visibility and we can do the same thing here. We can say subobject equals new subclass, and then instead of accessing public property off of the base object, I'm going to do it off the subobject. So run it again, and again public properties and methods can be accessed anywhere in your code. Let's go to our base class and we'll now add a protected property. And again, for the default value, I'm just pasting in the rule. Let's remind ourselves what that rule is. Protected properties and methods can only be accessed within the declaring class or from a subclass. So this base class is the one where we're actually defining the property, and so that is our defining class. And then it says that it can be also accessed from a subclass. But what that does mean is that I can't just access it in this visibility file like we did here. Let's give that a go. So I shall just comment that out, and I'll leave the stuff in there. I'll just comment it just so if you want to revise it, then it's all available to you. So base object, or print base object, and then protected property. As you can see, we're getting a red squiggly line there, so that's probably indicating to you that there is a problem with this, but we'll go and run it anyway and we'll see what kind of errors we get. Okay, and so we get a PHP fatal error, uncaught error, cannot access protected property base class protected property in the visibility file, because the only place where we'd be able to do something like this, where we'd be able to access protected property, will be actually inside the base class or inside the subclass. So let's do both of those things. I will create a accessor method. So remember the getter methods that we've done in previous classes, they are referred to as accessors. So public function get protected property, and so this will return a string, and so all we're going to do is just return it. So return this protected property, and because it is inside the declaring class where we are accessing it, then that is fine. It falls within the rules. Protected properties and methods can only be accessed within the declaring class or from a subclass. So let's go back to visibility, and here, instead of trying to access it directly, we're going to access it through a method. But you'll notice that the method is public. And what does that mean? I can access public properties and methods anywhere, which means I should be able to access the get protected property method in the visibility.php file. Let's go and run this. Okay, and so now we see protected properties and methods can only be accessed within the declaring class or from a subclass. And of course, with that method being public, it means that I will be able to also call it off of the sub-object. So we'll do that again. Protected properties and methods can only be accessed within the declaring class. Okay, so that's fine, but what we'll do is we'll actually go and create we'll access it more explicitly by creating a method in the subclass which accesses that protected property. So we'll create a method public function. We'll call it getParent protected property, just to be explicit on what we're doing here. GetParent so that's going to return a string, and so we still say this, and then it is protected property, and we have access to it because if we look at the rule again, protected properties and methods can only be accessed within the declaring class or from a subclass, and so we are accessing the protected property from a subclass. If you're finding this really easy, then apologies, but I'm just being very explicit in covering everything just for people that don't find it as easy to follow. When I first started doing this, it was a bit confusing to me, so it's good to try and cover a little bit of everything, and I'll leave stuff in the visibility file and I'll leave it commented out just so that you can have a play with it and confirm anything that you're a little bit unsure of. So here, print subobject, we're going to say this time getParent protected property. We can do this in the visibility file because the method is public, so we have access to it in anywhere in our code. Let's go and run this, and we should see the same message. So protected properties and methods can only be accessed within the declaring class or from the subclass. And so we've proved those two parts of the rule. Now let's move on to private. So back to our base class, and here we're going to add another property, and this time it will be private. I'll call it private property, and again for the default value we'll just paste in the rule, which is private properties and methods can only be accessed within the declaring class. They are not visible anywhere else. Basically the only place where I'll be able to access private property will be inside of this base class. I will not be able to go to subclass and access it in the same way I did with the protected property, and also I won't be able to access it in the visibility file, but we're still going to try that anyway. We shall comment that line and we'll say print base object private property, and then we'll add our end of line. Let's run this. PHP fatal error. Uncaught error. Cannot access private property base class private property in the visibility file. We do not have access to it here. But again, just like before, we can access it within the class which defines it. So let's go and add another getter here. We'll make it public and we'll call it get private property. So this is going to return a string, so return this private property. So again, sorry to sound like a stuck record, because this method is public, it means that we can access it inside of our visibility file, and so we're getting sort of access to the private property by proxy. So get private property. Okay, so private properties and methods can only be accessed within the declaring class. They are not visible anywhere else. We've been able to print this here because we accessed it inside a public method, and then we were able to call that public method anywhere in our code. So what if we want to access it in our subclass? This shouldn't be allowed because, a little reminder, private properties and methods can only be accessed within the declaring class. They are not visible anywhere else. So basically by saying they are not visible, it means that our subclass shouldn't even be able to know that this private property exists. Let's go over to our subclass, and again we'll create a similar method. GetParent private property, and so we're going to return this private property, And as you'll see there, PHP Storm isn't giving me any auto-completion. It's basically saying it knows nothing about this private property in this class. So let's go to our visibility file and let's try and access this. We'll comment that line there and we'll say print subobject get parent private property. We'll add our new line on the end there and let's go and run this. Okay, so fatal error, uncaught type error, subclass get parent private property, return value must be of type string, null returned. So probably not what you're expecting there. Basically null is being returned from this method, but you might have expected a different error to say that we can't access private property. Let's actually go and return or remove our return type declaration, and then we should see a different error if we do this. Okay, and so we get a PHP warning, undefined property, subclass private property. Basically it's saying that it's undefined, it has absolutely no knowledge of it whatsoever. It can't even tell that we are trying to access a property which comes from the parent. It knows nothing about this, it's simply not visible to the subclass. So hopefully you should have a fairly good grasp of visibility there. We've only really looked at properties, but let's have a quick look at methods, just a brief look there. So in our base class we accessed this method from our subclass, didn't we? Because it was public, which meant that we were able to access it. We can also access protected methods in our subclass. So first off, what we'll do is we'll change this get protected property to protected. And so if we went to our visibility file and we'll comment this out and we'll try and access that method here, first off the base object get protected property. So with it being protected, what does that mean? It means that we cannot just access it anywhere in our code. We can only access it from the class which defines it, which is the base class, or from a child class. So if I try and run this now, we should see an error. Okay, so that's what we get. Call to protected method base class get protected property from global scope. So we're trying to access it in somewhere which is not inside the base class or the subclass. So let's actually demonstrate how we can access it in the subclass. So we'll go here, and where we're saying get parent protected property, what we'll do is we'll call that method which we can access in our subclass because it is a protected method. So get protected property, and then if we go to our visibility file and we shall comment this out actually, and we'll just say print subobject get parent protected property, and then we'll put our new line on the end there and we'll make a little bit more space for us. So thinking about this, we're calling a public method from the subclass, which is in turn calling a protected method on the base class, which we can access because we can access protected methods and properties in subclasses. Cover quite a lot of scenarios there. I don't want to confuse you anymore if you're already a little bit confused by this, but rest assured we'll be going over this stuff and including it in all the future videos, so it'll be second nature to you after you watch a few more videos, and you'll get to grips with it quite quickly if you're not already fully understanding. But let's go and run this now. So what we need to do is just run it. Basically we'll go and run php visibility.php, and so now we're able to access it. Why are we able to access it? Because the method which we are calling in the visibility.php file is a public method on the subclass, and we are calling and inside of that method we are calling a protected method on the base class, which we are fully able to do. Next we'll examine why we have visibility and why it might be useful to us. In this one we're going to have a look at encapsulation, which is one of the four main principles of object-oriented programming. So I've already looked at inheritance and we've seen why we have that and how it works. We're also going to be looking at polymorphism and abstraction, but we'll get to that later on. They're a little bit more complex. But in this one, we're going to look at encapsulation, which refers to the bundling of data with the methods which operate on that data. So I've already had a look at visibility. We've looked at public, private, and protected keywords. Encapsulation kind of goes hand in hand with that and helps it all work and helps it all come together. Here are some nice clear reasons of why we use encapsulation, which I found on an online programming community page. The functionality is defined in one place and not in multiple places. It is defined in a logical place, i.e. the place where the data is kept, and the data inside our object cannot be unexpectedly or unwantedly modified by external code in a completely different part of our program. The way I'm going to demonstrate this is we're going to go and revisit our old friends. So we have the song and we have the playlist, which we used in chapter 1. You'll notice that my playlist class is quite sparse now. I've just left it with one public property, which is a songs array. And so before we get into this, let's go and create a file where we can have a play around with this stuff, and we'll just call it encapsulation. So just a normal PHP file, it's not going to be a class. We're going to require our classes into this file here. So we'll say require once, and we'll get our playlist and our song. So require once playlist.php, do the exact same thing for the song, require once song.php, and then we'll create one of each. So in fact, first we'll create a playlist. I'll just call this Beatles songs equals new playlist. Okay, and then we'll create a couple of songs. I'm going to create a genuine song, then I'm going to create one which isn't actually a song object. It's going to be a fake one using a string. So you'll see what I mean by that in a second. So we'll call it song equals new song. So this is a genuine song object. Give it the name of yesterday and 100 plays. So just a reminder, if we go to our song, the constructor takes a string for the name of the song and an integer for the number of times that the song has been played. And then we're going to say fake song, and then we'll just say this is not a song, it is a string. So let me now show you something which will demonstrate what encapsulation is about and why we have it. If we look at our playlist, I just have one public property, which is songs, which means that I can do things like this. Beatles songs, songs. So I'll add the genuine song, and then I'm going to do the very same thing, but I'm also going to add the fake song. And then I'm just going to go and file dump Beatles songs, songs. Okay, and so let's go and run this. So PHP encapsulation.php, and so what did you expect? Because this is our result. Both of those have been added to the playlist's songs property. So we have an array with 2 items. I appreciate it's not very easy to read in just this plain old black and white, but there you can see the first item in the array marked with index 0, and that is an object of song type. And then you see our second item in the array, which is a string. And so do we really want to allow strings into our playlist of what should only be songs? We need to find a solution to this. The first step I'm going to take is to prevent this arbitrary adding of anything to the Beatles songs array. The quickest and easiest way that I can do that is to go over to my playlist and just make this songs array private. And so now if I actually go back to my encapsulation file, you'll see that we get some squiggly red lines underneath here. So PHP Storm's telling you something that this might not be possible. If we actually go and try and run this, and so now we get a big angry error, PHP fatal error, uncaught error, cannot access private property playlist songs in encapsulation, and that is on line So after the colon, after the file name there, encapsulation.php, you'll see a colon and then the number 11. I'll just make this a bit small to make it all in one line. Okay, and so our problem is on line 11, and that is where we're trying to access a private property here. So we can no longer do that. We need to come up with another solution. I'm going to get rid of this stuff here, and then we'll go over and have a look at our playlist. So looking at this now, do you know what the solution would be in order to only be able to add song objects to this songs array? If you do know the solution, or you think you can have a go at it, then by all means pause me now and give that a go. Let me show you what the solution to this is. So we sort of touched on it in chapter 1 when we were looking at accessor methods, when we introduced getters and setters for the first time. So what I'm going to do here is create a public function. I'm going to call it add song, and then here I'm going to make it type declare songs, so I can only pass in song objects to this method. So that will be a song, and then I'm going to say void, because this method will not return anything, but what it will do is we'll say this songs, and we will add that song to our songs array. And so if I go back now to the encapsulation.php file and I say Beatles songs, add song, and I try to add the fake song, and then we go and run this, and so now we get a PHP fatal error, uncaught type error, playlist add song, argument number 1, song must be of type song, string given. And so now we have that protection. I can't just go and add anything to my songs array, because we've taken one step, which is to make our songs property private, and then we've taken a further step. So there's only one way now of adding a song to that songs array. It means you must use the method which operates on that data. Remember what we said at the beginning of this recording. But we have type declared song here, so we cannot just add a string or try and send in a string, because we'll get a PHP fatal error. We're completely protected from adding the wrong kind of data to this songs property. Okay, great. So let's go back to our encapsulation.php file and we'll add our genuine song. But here you'll notice now that I can't actually just var dump Beatles songs, so we're unable to inspect our songs property that way. So I'm going to let you have a go at this again yourself. How will we get access to our songs property now that we've made it private? Should be fairly easy to you now, so give that a go. Okay, so you probably thought that we're going to need an accessor method and a getter in order to access that. So if you thought that, well done. Public function get songs, and so this will return an array, because our songs property is an array, and all we're saying is return this songs. Okay, and so back to our encapsulation.php file, and what we want to do now is just say Beatles songs get songs. So let's go and run this. Okay, perfect. So we have an array, it has one item, so that's what the little 1 in the parentheses means there, index of 0, and that is an object of type song. The 2 in the parentheses means that it has 2 properties, by the way, and so property 1 is the name, which is a string of 9 characters, and the value is yesterday, and then number of plays is an int with a value of 100. And so there I think we've nicely demonstrated the reasons why we have encapsulation. If you remember what we said at the beginning, the functionality is all defined in one place. So in one place for songs, the functionality is defined in a logical place, i.e. with the data which it will operate on. And also it means that we can't, our data can't be unwantedly or unexpectedly modified by external code. You can only act upon this data by the methods which are defined in the same class as it. In this one we're going to have a look at something called typed properties, which is an extra way of giving yourself some protection over what kind of or what type of data can be stored in variables. And so we're in the chapter 3 folder still, and so let's go and create a new file, and we'll just call this typed properties.php. So typed-properties. Okay, great. And so what I'm thinking of doing is using our song, which we've been using up until now. So what we shall do is require once song.php, and then what I'm going to do is I'm going to create an array of song titles. So there we have an array with 3 song titles. Now let's go ahead and create a song object. So song equals new song, and so what I'm going to do is I'm going to rely on that array of song titles in order to populate the title property, or the name property as we gave it here. And so we'll say song titles, and we'll just get the first item from the array, which we can do with index 0. And so now the name of the song should be yesterday. The second constructor argument is the number of plays, so we'll set that to 100. So hopefully nothing you've seen here is new. This should all make sense to you. Let's go and actually var dump the song name. And so in chapter 3 I'm going to run PHP typed properties, and so we get a string with 9 characters and the value is yesterday. What if we wanted to assign a new song name on the fly? We can actually do this because it is public. The name property is public on this, so we can go and give this a new name. And so let's do a similar kind of thing to what we've done here, where we just took index 0 of the song titles array. Let's mix it up. We'll use index 1, so the song name should now be help, and let's actually go and var dump the song name. Okay, and so now the song name has been set to help. Okay, and so these are kinds of things that you'll do in programs. You'll go and access different indexes on arrays and things, and sometimes there might be a mistake in the programming and you might not access it as an array. You might completely forget that part. What would happen if we went and did that now? Oh dear, we've actually set the song name to an array of 3 different titles, so that's not great. We could do with some better protection. So can you think of ways in which we could actually prevent that from happening? If you think back to the last lesson, we used getters and setters. So we said that you could only set certain properties using the setter methods. It's part of encapsulation. But in this one, what we're going to do, because this is public and just to demonstrate typed properties, I'm actually going to show you how you can prevent this from happening on your properties directly. So here I'm going to say that the name property must be a string, and so when I go and try and set it to an array here, hopefully we should get an error. Okay, perfect. PHP fatal error. Uncaught type error, cannot assign array to property song name of type string. So we've tried to assign an array to it, but you can only actually assign a string to it as we've specified here. And so that is typed properties and how they work. All very simple, very similar to what we've been doing, where we've given type hints in our methods and things like that. You simply put the type in front of the actual variable name, the property name, and the work is done for you. One little caveat, you can only do this with PHP 7.4 or greater, because it wasn't introduced until PHP version 7.4. Let's finish off with a nice, really easy challenge. What I want you to do is do the same thing for the number of plays, and then just go and try it out in the typed properties file. Okay, so you shouldn't have had any trouble with that. So we've said the number of plays must be an integer, and then we can go and try it out here. So I'll just comment out some of this stuff here, and we'll say song number of plays equals, and again we'll set this to an array saying 300 and 200, and so then when we go and var dump this to try it out, var dump song number of plays, again we get an error. So PHP fatal error, uncaught type error, cannot assign array to property song number of plays, which is of type int. In this one, we're going to have a look at something called union types. So up to now, we've just said that, for example, this name here can only be of one type, can only be of type string. But you can actually set it up where it can be multiple different types. And so I'll show you how we can do that. And so for this, I'm going to create a property called rating, as in the song rating, and I'm going to make it private because I've got an idea for what we're going to do with this. And so private, and we'll say rating, and then we need to go and give it a type. And so I'm going to give it two types. This can be either an integer or it can be a float, and so we'll allow it to be like in between ratings, such as 3.5. And so what I'm going to do is I'm going to add something called a doc block here. So sometimes if you want to put comments in your code, in object-oriented code, you can add doc blocks above method names, above properties, just to explain why you've done things in a certain way or how it's supposed to work. So for this one, I'm just going to add some rules and then we'll talk through those. We're saying that the song rating goes from 0 to 5, so it can't be less than 0, it can't be greater than 5, and like I say, half ratings can be allowed, and so by allowing floats it means that we can have values such as 3.5. So let's go over to the chapter 3 folder, our root of the project, and create a PHP file called union types where we can go and play around with this stuff. And so here, like before, we're going to require once the song, and then let's actually just go ahead and create a song. So song equals new song. Again, we'll give it the same title and number of plays. And we said that our rating property was private, and so there's no way that we can access that directly. We're going to need getters and setters. So this recording is going to be in the form of a challenge for you. So let me paste in the steps. This is going to touch on a few things that we've done, so it should consolidate quite a bit of the learning that we've done. So first off, add functionality for setting and getting the song rating. So we want to be able to set the song rating, and we also want to be able to retrieve it. We need a getter to retrieve it. And so if you think back to our encapsulation lesson where we wanted to provide unwanted access and unwanted modification of our properties, we're going to do that kind of thing here. So we don't want the rating to be set to anything less than 0 or anything greater than 5. So if this was a public property, then we'd have no protection. People would be able to go and set it to whatever value they want. But because we're going to have a method, I'd like you to add some logic inside of that method to prevent people from doing that, to prevent them from making it less than 0 or greater than 5. And so the rules are, if that someone attempts to set it to less than 0, then set it to 0. If someone attempts to make it greater than 5, then set it to 5. What I'd also like you to do is when you're type hinting the returns and type hinting the parameters, I want you to also use union types. So say for example I was type hinting this, I could say int and then pipe and then float. So use that in your method signatures and also in your return types. Anyway, I'll show you the rules again. Pause me now and have a go at this. So this is my solution. I'll make a little bit of space here. So first off, we'll create a setter. So public function set rating, and this can be an integer or a float, and then we are passing in a rating variable. We won't return anything from this because we are just setting a value, so nothing needs to be returned, but we need to have a look at those rules. And so I'll copy those and I'll just paste them in there to remind myself. So if less than 0 is attempted, set to 0. So what I can do is this, rating equals max, and so this will choose the highest value of 0 or rating. And so in other words, if the rating is less than 0, say for example if this was -1, then it would choose 0, and so that means that we'll never ever be able to go below 0. Okay, and so we then set that rating value again, and then what we can do is we can now say this rating equals, and then what we're going to do is we're going to say min, and then same again, we're going to say 5 and rating. So this is our rating that we've got back from the max function, and here what we're saying is that the value cannot go higher than 5. So say for example if this was 7, then it would choose the minimum value, and therefore we'll never have a value which is higher than 5, and so we'll never have a value which is lower than 0, and we'll never have a value which is higher than 5. Okay, so I'll strip out those comments because we don't need those in there anymore, and then what we need to do is we need to go and create a getter, which will be much simpler. So public function get rating, and this time we are returning something which can be an int or a float, and we're saying return this rating. Okay, perfect. So let's now go back to our union types file, and we'll start off by setting the rating. So song set rating, and first off we'll just set it to 3.5. so perfectly allowed, it's not greater than 5, it's not less than 0, so we're just going happy path for the time being, and what we'll do is we shall print song get rating. So over to the terminal, and it is PHP union types, and so as you can see we get 3.5. Let's add our new line on there so it prints it nicer. Okay, 3.5. How about if we attempt to make this -4? So now because the value is less than 0, it defaults to 0. How about if we make it 9? And so as you can see, total protection there, we've tried to set it to a number which is greater than 9, and it gets set to 5 by default because that is the logic which we set in our set rating method. So how did you get on with that? I hope you had a go at it. A little bit more to think about there, but I think that was quite an interesting challenge. I used to like doing stuff like this when I was learning, but unfortunately not enough courses give you the chance to do stuff like this, so you end up just watching, and the knowledge doesn't really sink in as much if you're just watching like Netflix or something. If you're actually having a go at it and thinking about something, then it makes the knowledge a lot easier to sink in. So we'll carry on doing more of this stuff. Hope you're having fun. In this recording we're going to have a look at something called static properties. Static properties differ from regular object properties in that you call them directly off of the class rather than an instance object. So what do I mean by that? Let's go and create a class where we can have a play around with this. So I will call this counter, and I'm going to create a static property. So pretty similar to how you create normal properties, except after we declare the visibility, we then add the static keyword. So public static, and then we can do our type declaration. So we're going to say this is an integer, and we'll give it a name of count, and we'll initialize it with a value of 0. So let's now go and create a file where we can play around with this, and so I'm going to create one called static properties, and we shall require once counter.php. Like I say, static properties belong to the class scope, so it means I don't have to create a new counter object in order to be able to access static properties on it. And so the way I can access it is like this. What we'll do is we'll print this out, so counter, and then we get 2 colons. So in order to access static properties, we access them like this, rather than using the object operator, the right arrow, which we do with objects. So print counter count, we'll add our end of line, and we'll just go and run this. So php static properties.php, and so we get a count of 0. And so if I wanted to increment that count, all I would need to do is say counter colon count and then plus plus. That should increment the value by 1. And so if I go and print it now, we now get 1. So I can drop a few of these in there. We'll go and run it again. And so we now get 4. So I'm sure you get the picture there. You might be wondering, why is this useful to me? And so first off, one thing about static properties, it means that they are available anywhere to you in your script. So say for example, we'd created an object of counter, but we wanted to access it later on to get at that count value somewhere else in our program. It would be very hard to go and be able to access that original object that we might have created in a completely different file. Whereas when you're dealing with static properties, it means that that value is held. Anytime I just go and say counter colon count, means I have instant access to that value. Another reason is, as you saw there, it was very simple to set up. I didn't need to create an object. All I had to do was just say counter colon count and I had instant easy access. And another reason is that the static property is available to every instance of the class and holds the same value for every instance of that class. So it makes it possible to keep track of particular values, and that's what we'll go and demonstrate now. I'll create a new class and we shall call this connection. And so you can think of this as like a connection to a virtual conference, an online conference or something like that. And so we're going to have an example where we keep track of the number of connections. And so I'm going to create a public static property. So public static, we'll say this is an integer, and again we'll go with count and we'll initialize it with a value of 0. And then I'm going to create a constructor. And so what I want to achieve here is that every time a new connection is created, so every time we say new connection, then we want to increase this count by 1 to say that a new connection has been added. And so the way that I access static properties from within the class is I no longer say this, because it is not referring to an object. This always refers to an object. However, we are referring to the class. We're looking at class level scope, and so the way that we do it is we use a keyword called self, and again it's colon and then all we do is say count, and I'm just going to say plus plus, so that will increment the count by 1. Back over in our static properties file, I'm just going to comment this stuff out because we don't need that at the moment, and then we shall require once connection. And so connection 1 equals new connection. That should have incremented our count, so we should now be able to print connection count, and we should get a value of 1. Let's go and run this. Okay, and that's exactly what we get. Let's actually create a second connection now. So what I'll do is I'll copy that, drop that down there, I'll call that connection 2. So we've now created our second connection. Our count should be 2. Let's go and check that. Run it again. And so the first time that we print it, we get 1 because we've just created one connection, and then we create a second connection and we go and print the count again, and then we get a value of 2. Just behind the scenes, I'm going to go and change the count property to be non-static, just to demonstrate what the difference is and how using a static here is beneficial to us. So what I've done there is I've removed the static keyword from this line, and here where we were saying self count, obviously, or maybe not so obviously to you, but we can't do that anymore because it's no longer static, and so we are accessing count of an object. This always refers to an instance, an object of the connection class, whereas self refers to the connection class itself. Over in static properties, I've also made the required changes, so now we're no longer accessing count of the connection at connections class scope level. We're accessing count of an object because it's no longer static. And so what is going to happen here is that connection 1 will have its own count, and connection 2 will have its own count, and those count values, or those properties, will have no knowledge of each other. So the connection 2 count will be completely separate from the connection 1 count, meaning we will get this. And so we just have one for each of them. To finish off, I'm just going to change this back to the way it was. And so we'll change that back to there, self count and public static count. Okay, so we'll run this again, so we should see 1 and 2 again, but same old problem. Our property is public, which means that I can go and do stuff like this. Connection count plus equals 20, and then if I go and print that, we now get a connection count of 22 because we've been able to just go in there and do what we want. However, I don't have 22 connections, I only have 2 connections, so I need some protection from that. And so the way that I'd protect myself from that would be to make this private, and that means that I'd also need to access it somehow using a method. And so that's what we'll look at in the next one, where we take a look at static methods. Okay, so we want to avoid this, don't we, where we have this count static property, but we should only be incrementing that count when a new connection is created. So if you look at the constructor, we increment it there, but because it's public, it means that we can just access it and increment it anywhere in our code. So we ended up with 22 connections, even though in reality we only had the 2 connections. So how do we handle this? Same way that we handle it with non-static properties. We go over to our connection and we now change this to private. And so to have a play with this, let's go and create a file called static methods, because in this one that is what we are looking at. So file name is static-methods. We shall require once our connection.php file. So before I create a static method, let's have a look at what would be the consequences, or what would our scenario be if we just created a normal method, i.e. a non-static method, and we just call this get count. Okay, so our count is an integer, we're going to return an integer, and so here we would need to say return, and it would be self : count, because it is a static property. We cannot access it using this because it does not belong to an instance, it belongs to the class. So sorry that I keep repeating that. So as you can see, we've got the squiggly red line, we won't be able to do that. So the only way we can access a static property is using, well, it's not the only way, but I'll show you another way later, but the only way that we know for now of accessing a static property is to use the self : but there's a problem with this, because our count is initialized as 0, so it's possible to have 0 connections. However, if we don't actually have an object, how do we go and access that get count method? Because we can only access the get count method of an object, an instantiation. We would need to say connection equals new connection and create an instance of the connection class. But what if we want to count the number of connections even though we might not actually have any? It doesn't really make much sense that we actually have to create a connection in order to be able to see how many of them are in existence, because you're always going to have at least one that way, whereas sometimes we might want to know how many connections we have even though there are no actual connection objects have been created. So static methods to the rescue. Here, instead of it being public function, same as what we do with properties, we say public static function. And so here I can actually get rid of that instantiation, and I can just print connection get count. We'll add the new line on the end there, and we'll go and run this. So PHP static methods, and so as you can see we get 0. So if I did want to create a connection like so, if I then go and run it again, as you'll see we now get 1. And so that is a fairly quick introduction to static properties and methods. There is more to it, and we'll be touching on some of the extra things that you can do with static properties and methods as we progress. In this one we're going to have a look at class constants. If you've done some procedural PHP up until this point, then you're probably aware of global constants and you may have used those. So in this one we're going to look at class constants, which are the same thing except they belong to a class, and they just make the whole system more cohesive when they are related to a particular class. So let's go over to the chapter 3 folder and we'll create a file where we can actually play around with stuff first. And so I'm just going to call this class constants, so class hyphen constants. Okay, so when I was talking about global constants, what I meant was this, where you might have done it this way, where you use the define function and you define a constant name. So what we'll say here is we'll call this created, because that's the example that we're going to use when we do class constants, and then we'll say that the value for that is 201. And so then when we go to print created, which we access like this, so exactly the same except without the quotes which we saw when we defined it. So print created, we'll put our end of line on there, and we'll just go and run this. And so interesting, actually, we've actually been using global constants all along, haven't we? Because we've been using this PHP underscore EOL, which is a global constant which evaluates to a new line character, and that's part of core PHP. Anyway, let's go and run this. So PHP class constants, and so we get a value of 201. The other way to define them would be to do this, const and then created. So this time we're not using the quotes. Const created equals 201, and then if we run it again we should get the same result. Let's go and create a class now where we can define some class constants. So create a new PHP class. I'm just going to call this HTTP, as in HTTP request response. So here we're going to define some constants which represent HTTP response codes. And so the way that we can do this is we use our visibility keyword. So we'll go with public and then const and then the name, no quotes. So for a not found we would do it like this. So the typical convention is to use all uppercase letters. That's what you'll see throughout most of or all of PHP really. So stick to the most common conventions. So public const not found equals, and not found response code is 404. We'll add a couple more in there. So I'll have one called OK, which will be 200, and I'll have one called created, which was what we used in the global constant example. So let's think about this. Not found is a fixed value. Not found will always be 404. So this isn't something that you'd want to change. So you want it to be a constant value. Constants cannot be changed. Once you define this, once I define not found as 404, it is that forever. So it makes sense for things which are going to be fixed, such as response codes which do not change, then constants are definitely the way to go. Let's go and have a little practice with this, and I'll show you how we use them when they are defined on a class. So let's remove some of this stuff here, and we shall require once our HTTP file, so http.php, and we don't need to create an instantiation. Much like static properties, they belong at class scope, they belong to class level, so you access them directly off of the class, no object needed. And so let's print HTTP, and we'll print our old friend created there. Let's go and run this. And so we get 201. Just to mix it up, we'll do not found also. As you can see, we get 404, and so Again, like I say, these are constant values, so I cannot change these. If I do try to change them, so if I decided to say HTTP not found equals 500, if I go and run this, we'll get an error. It might not be the error that you think we will get, it might surprise you, but this is what we get. PHP parse error, and it's saying that we have a syntax error, unexpected token equals sign in class constants on line 5. So you can't reassign constants. Once you've created them, they are fixed forever. So it's basically saying that by putting an equal sign after we've accessed the constant, it's given us a syntax error because it's just not possible, or just not something that you would do. You would never try to assign another value to the HTTP not found constant once it has already been established inside of the HTTP class. So just to round off and to recap and just cover anything which I might have missed, I didn't explicitly say so, but class constants are accessed using the 2 colons in the same way as you do with static properties. The one big difference between constants and static properties is that the value of static properties can be changed. Constant values are what they say on the tin. They are constant values and they cannot be changed. Now let's have a look at something called abstract classes. So abstract classes are classes which you don't instantiate themselves. Instead, they define an interface for classes which extend them. And so what do I mean by that? We're going to go back and revisit the example we used with the book, and we also have a physical book. I've made them a bit smaller. I didn't include author and price because I want to stay focused on what it is that I want to show you. So for our book, we just have one property, which is title, and then we have the physical book, which extends book, and that has added a weight property. So like before, we invoke the parent's constructor like so, parent : construct, and we need to pass the title to that. So if you look how our book is constructed, it needs a title, and then we add a weight for the physical book, and so it just has one of its own custom methods, which is get weight. So thinking about this, we created a physical book and we created a digital book, although I've not actually recreated that here. I'll let you have a go at that shortly. But looking at our book, it's something which is always going to be extended, because it's always going to be extended with the actual type of book, such as physical book, digital book, or any other kinds of book. So this isn't something that you'd want to actually instantiate itself. You would instead instantiate a subclass. And so for that reason, we can actually make this class abstract, which would actually prevent a client coder from trying to instantiate it. And the way that you do that is you simply prefix where we say class book with abstract. Let's go and create a file where we can have a play with this. So in the chapter 3 folder, which is where the book class now resides and where the physical book class also resides, I'm going to create a file called abstract classes. Okay, so here we shall require once the book, and we shall also require once the physical book, and then I'll try to instantiate a book. So book equals new book, and then we'll try and call the get title method off of that. So book get title, and we'll add our new line on the end there. So you're already probably seeing the red squiggle here, so you're guessing that something might go wrong, but let's go and run it anyway, just so that we can see what does go wrong. PHP abstract classes.php, and so we have a fatal error. PHP fatal error, unquote error, cannot instantiate abstract class book. So you cannot instantiate an abstract class. And so, like I say, what are the purposes of abstract classes? Well, it defines an interface, because any child of the book will have a title, and so we can actually set up the title property, and we can add a getter for the title. And so we're defining a little bit of functionality, and we're also defining the interface. And then all you need to do is just go and extend it with a physical or a concrete subclass, and then that is where that is the class which you would instantiate. So let's actually go over and do that now. So here, instead of trying to new up a book, I'm going to say book equals new physical book. And for this one, we're going to need some arguments. So in fact, we would have needed arguments for a book. We would have needed a title, but never mind that now. So book, physical book title, we'll say Hamlet, and the weight will say 500 grams. And then we shall go and run this. And so now it's back to the way it was. Everything is running. We've extended an abstract class with a physical class, and then we've accessed what was actually a function which was defined on the abstract class. So even though we've declared it abstract, you can still access the properties, still access the methods. The one thing you cannot do is actually create an instance of it. Now let's look at something which is related to abstract classes, and that is abstract methods. So again, sticking with our book class here, if you recall what we did in previous lessons involving the book, we had a write method which we then overwrote with the write method in subclasses. But what we're going to do here is create an abstract write method. And so what that means is, again, it's not a method which will be called on this book class, but we're defining an interface for our subclasses to implement. And so by creating an abstract method called write in the book class, it means that every class which subclasses the book must define a method called write, which has the same signature as the one which we define here. So the way we do this is start off with the word abstract, and then visibility, function, and then the name of it, which in this case was write. Not going to take any arguments, but we are going to type int a return type, and that will be string. And so if I now go to my physical book, you'll see that PHP Storm is complaining at me here. We have a red squiggly line. If I hover my cursor over that and then look in the bottom left hand corner here, it says class must be declared abstract or implement the method write. And so because we're extending the book class, and because the book class has an abstract method, it means that we must now go ahead and implement that method and its functionality in our physical book. You'll notice that in the book class we didn't define any functionality. We didn't add the curly braces which you see on these methods here, on the non-abstract methods. We're simply saying that this is an abstract method called write, which means that in the subclasses, again, you must implement that method. And so let's go ahead and do that. Public function write. And so notice that here I didn't say abstract public function. We are creating a concrete function now called write in our concrete subclass. Okay, but we have the red squiggly line because the signature is not exactly the same. In order for it to match the parent, we must also type int the return type. And one other thing I should tell you about this is that you can't make the visibility more strict. So if the visibility is public here, I cannot then go make it something which is more strict, such as protected. It won't let me do that. And as you can see, we get the error in the bottom left hand corner, cannot make public method book write protected. What you can do, however, is make it less strict. So if we said abstract protected function write, I could make it protected, and I could also make it public. Notice no red angry squiggly lines. However, if I wanted to make it more strict, then I would not be able to do that. You cannot make the method in the child class more strict than that in the parent. Okay, so one to remember there. We're going to stick with public, And then we're just going to do the same as what we did in the previous chapter here. We're just going to return a string which would be a combination of the title and the weight. So return this title, comma, weight, colon, and then this weight. Okay, and so let's go over to our abstract classes file. We'll not create a separate file called abstract methods to test this out. We'll just stick with the same things. And so here we're going to print the book title, and what we'll also do is we'll say print book right, and again we'll add on our EOL, and if we go and run this, okay, so now we see the title, and then we see what gets written, which is Hamlet, comma, weight 500. Okay, perfect. Okay, and so now that you've seen what I've done there with a physical book, why not have a little practice yourself? If you remember in the previous chapter we had the digital book, and the one main difference was instead of having a weight it had a file size. So entirely optional, but it's a nice bit of practice for you. Create a similar thing but for the digital book. Make that change to the property, use a file size property instead of weight, and then come up with something to print it out and just go and have a little bit of a play with this in the abstract classes PHP file. Congratulations on getting this far. If you feel that now you are getting to grips with the basics and you're feeling fairly confident about what you've learnt, then I'd say that you're well on your way, and you're certainly at a level where you can now go and tackle the full course. The link to that course details is below this video in the description. If you have any questions about the course, then feel free to reach out to me in the comments. I'll see you there. If you've enjoyed this video and you'd like YouTube to show you more of my content, all you need to do is subscribe and click the notification icon. Each week I release a number of new recordings. If you'd like to be informed about my upcoming videos, as well as receive exclusive content, discounts and early access to my new videos, you can join my mailing list by following the link underneath this video.